In this experiment we are going to prepare nano copper, nanometer scale fine particles of copper metal, which is a useful catalyst for some organic reactions. Start by weighing out 10 grams of anhydrous copper sulfate. You can also use hydrated copper sulfate. Simply adjust the weight according to the same number of moles of copper. Now we need to make a saturated solution of copper sulfate. So measure out 25 ml of water to begin with. Note that using saturated solutions is important in this reaction to get a good yield. Let's remind ourselves how anhydrous copper sulfate behaves with water. Blue hydrated crystals are formed, and quite a bit of heat is produced. Now we'll add the rest of the water. You'll need to stir quite a bit and break up the crystal in order to get this to dissolve to form a saturated solution. You may need to add a little more water, but not much. Here's our slightly warm saturated solution. About 35 ml in total. Now measure out 24 grams of ascorbic acid. We're using pure food grade vitamin C here, which is the enantiomer of ascorbic acid. You may be able to use a lower grade, but we've not tried this and we're not sure if it will affect the reaction. Again, we need to make this into a saturated solution, so we've measured out 60 ml of water. We'll start by adding 30 ml to see how much will dissolve. Ultimately we ended up having to use nearly all the water we measured out. So now we've got two saturated solutions. Copper sulfate on the left, and ascorbic acid on the right. Add the copper sulfate solution to the ascorbic acid. The dark green solution is immediately formed. Let this stand for just a few minutes and you'll see something happening. Orange-colored sparkling metallic copper starts to be deposited on the side of the beaker. And you can start to see tiny particles of copper forming in the solution and on the surface of the liquid. You can now leave this solution for a few days in order to react, but there's a quick and easy way to accelerate this reaction. Use a microwave oven. Place the beaker in the oven and use full strength 800 watt heating power until the solution boils. After a minute or so, check the solution. You'll see the copper deposit becoming a lot stronger. Use a spatula and scrape the copper deposit from the sides of the glass. Then when cooled slightly, place back into the microwave and heat to boiling again. Repeat this process and after 4 or 5 cycles you'll have a good copper build up in the beaker. At this point the reaction speed becomes very slow. So set up for filtration. We're using the fine grade for glass sinter, but you could also use good quality filtered paper just as well. Filter the solution using a vacuum pump. You can see that the filtrate is a lighter green color than when we started due to there now being less copper remaining in solution. Allow the copper to get quite dry on the pump. And then with the pump switched off and the vacuum released, add 50 ml of warm water. Stir the copper well to wash it and break up any lumps. You can see some green color are present in the washing water. Filter the water and then repeat the washing process using another 50 ml of water. Filter again, and then allow the copper to get as dry as possible by leaving it on the pump for 15 minutes and breaking up the powder with a spatula. We're going to use our nano copper as a catalyst for organic reactions, and so we need to get it as dry as possible. So we're going to wash with a little absolute ethanol to draw off any remaining water. Add 10 ml of ethanol to the copper precipitate and stir it well. Filter off the ethanol, then repeat the process using another 10 ml of absolute ethanol. Finally, allow the copper to dry very thoroughly on the pump. And here's our product: 1.92 grams of very fine and dry copper powder. This corresponds to a 48% yield from our starting copper sulfate. It is difficult to increase the yield of this reaction, because once the concentration of copper and ascorbic acid in the reaction mixture drops, the reaction becomes increasingly slow. So let's see how our nano copper reacts with concentrated nitric acid. Here we have a small amount of 68% nitric acid in a beaker. It's an extremely fast reaction, and the dense brown fumes of nitrogen dioxide form a toxic blanket across the work surface. Thanks for watching and stay tuned.